Hello, mathematicians. In this video, you'll learn about another type of equation you can use to describe a linear function, point-slope form. Point-slope form is super helpful to use when you want to write the equation of a linear function and you're given 2 points, or a table of data, or maybe even a graph. All right, so let's see what this new form of the equation is. It is y minus y1 is equal to m times x minus x1. Now, this equation is called point-slope form because in this equation, you can find both the slope and a specific point. So let's kind of decode it and look at all the pieces. So always, whenever you see an m, you know that's the slope. So the same thing here. And always remind you, slope is your change in y over your change in x. Next, the x and y with the subscripts, x1, y1, these mean the x and y values for a specific point, a point that you know. So this is a known point. So you know the x and y values for this point. And then finally, the x and y without a subscript, this is just representing any point, sort of the generalized abstract point. And you'll keep these as variables, just like they were x and y in your slope-intercept form. So this means this represents any point that's on the line. All right, so point-slope form, you have the slope and a known point from that. Occasionally, you'll see this, an alternative way of writing this equation, and I want to show it to you because some people prefer it, and they're equivalent. Some people like to have the generalized y isolated on one side of the equation. They'll say y is equal to the slope m times x minus x1 plus y1. Notice all they've done is added y1 to both sides. All right, so you can keep that as an option. Let's next work through an example to see this equation in action. In this example, we're going to write the equation of a line that passes through two given points. And for us, our points are -1, 3, and the other point is 4, -3. This is a great time to use point-slope form because we have a given point that we know. So to remind, point-slope form is y minus y1 is equal to our slope m times x minus x1. The first thing I want to do is I want to find the slope. I know the slope is my constant rate of change, how my y values change compared to how my x value changes. So I've got 2 points. That means I have 2 y values. So I'll start with 3 and subtract -3. And then my change in x values would be -1 minus 4. Remember to keep that order consistent. I used my y and x values from the first point, and then my y and x values from the second point. And that's going to be 3 minus the -3 is 3 plus 3 or 6. -1 minus 4 is -5. So I'll write that as a negative slope, -6/5. Fabulous. Now I can come in and substitute that in. -6/5 times x minus x1. All right, next, we need to use one of the points to substitute in for x1 and y1. And it doesn't matter which one. I'm just going to take this point and substitute that in. So now I have y minus my y value, y minus 3, -6/5 times x minus -1. All right, let me just quickly rewrite that to get rid of the double sign. And that's something that you might just do in your head as you're writing it in. So x plus 1. All right, so great. Here's the equation for our line. It's in point-slope form. Very often, what mathematicians want to do is they actually want to now take this equation and convert it to slope-intercept form. Slope-intercept form is so useful because it's isolating y and simplifying. So I want to first isolate y. I'm going to add 3 to both sides. And then once I've added 3 to both sides, I'm going to simplify by using the distributive property. Plus -6/5 times 1 And then when I add 3, I'm going to go ahead and write 3 with a common denominator of 5. So 3 is 15/5. And lastly, I'm going to add those fractions. And let's see, -6/5 and 15 will give me a +9/5. So great. Here I have it now in slope-intercept form. This is great if I want to find my y-intercept. It's easy to see. And this is also, since I'm in function form, I can easily input new values for x and find their outputs y. I wonder, what would have happened if we had used the point for -3 instead of -1, 3 when we went to substitute in our given point? Would we have gotten the same version of the equation in slope-intercept form? That might be one thing that you want to try and explore. Lastly, sometimes we're given an equation written in point slope form and we want to decode it to pull out the information. We can pull out both the slope and the specific point. So let's just first remind ourselves that it's y minus y1 is equal to m times x minus x1. So using this to decode, first my m is, my slope is going to be -2. Next, the point, I know I'm subtracting my x value, so I'm subtracting 1. So my x value is 1. And here I'm subtracting y, but it's +3, which would be the same as minus a -3. So we know the y value is -3. So that's a little bit subtle there. Um, Thinking when a number's being added that you're really subtracting the negative version of it. Great. So I now have this information and maybe I want to graph this line. I know because my slope is -2, it's going to be a decreasing line and it will be more vertical than horizontal. I'm going to start with this point that I do know and plot that. So 1, -3 will bring me down here. And now I can use my slope to walk this graph. So if my slope is a -2, I can think of that as -2 over +1 or +2 over -1. So if I start with this, that means -2, I'm going to go down 2 units, +1 to the right 1 unit. So down 2 to the right 1. If I'm thinking about it this way, I'm going to go up 2 and to the left 1. So both ways work. And there I'm going to have my points and I can draw the line connecting those points. And yes, indeed, it's a decreasing line and it's more vertical than horizontal. All right, so I hope you found this video helpful. You now know what point slope form is. Super helpful if you're given a point in the slope or 2 points. It's really the most efficient way to write an equation for a line. You might eventually convert it to a slope-intercept form, but point slope form is your starting point. It's also great if you're given an equation in point slope form, you can decode and find a given point that's on that line along with the slope. All right, please let me know if you have any questions. And until next time, math on.